Hello, this is Mr. Savage, and we're going to take a look at the first lesson that we're doing in Chapter 2, which is Lesson 3. And the title is The Percent Proportion. This begins on page 121 in your math book if you'd like to follow along there. So we're starting out here by talking about how to make comparisons. Again, we've been making comparisons since the first chapter when we were doing unit rate. Now we're taking a look at this little exercise here. Read about the monster trucks. The tires on a monster truck weigh approximately 2 tons. The entire truck weighs about 6 tons. Number 1, write a ratio of tire weight to total weight as a fraction. So we're making a part-to-whole comparison here of the monster truck's tires. The tires, all the tires on the truck, it says, weigh 2 tons. So you need to put a 2 as the numerator in your comparison. And then we are comparing it to the entire truck. The whole truck weighs 6 tons. So we're going to put a 6 as the denominator. So 2 over 6 is our comparison. Let's go on to number 2. Represent this fraction by shading in the model. So we have what we call a tape diagram or a bar diagram. And we're going to take that and we're going to shade it in to represent the fraction 2/6. So since there are 6 pieces of boxes on the tape diagram, we're going to shade in 2 of those to represent the part that we're talking about here, just the tires, 2 out of 6. Okay, moving on to question 3. Write the fraction as a decimal to the nearest hundredth. Now, a lot of people have trouble changing fractions into decimals, but a fraction is a division problem waiting to happen. So our fraction 2 over 6 means take 2 and divide it by 6, and you can use a calculator to do that if you want. But 2 divided by 6 is a repeating decimal number, so it actually has 3's that do not stop. And you put a bar over it to show that it repeats, but they want us to round it to the nearest hundredth. So that means that we're going to take it out 2 places past the decimal point, and we would call it about 0.33. That would be 33 hundredths. 33 hundredths for number 3. And then number 4, about what percent of the monster's truck weight is the tires? So it's pretty easy to change a decimal to a percent. All you do is move the decimal 2 places to the right and add a percent sign. So that would make this about 33%. The tires are about 33% of the monster truck's weight. We're going to be doing these kinds of part-to-whole comparisons in Chapter 2, and we are going to be setting up our problems as proportions and solving them. So we're ready to go on to the next page. So let's move on to page 122. On page 122, they are showing us some of the kinds of problems that we will be solving in this chapter. They give you examples of each type and show how it would be set up as a proportion. Before we look at that, let's go over here and have you write down what our model is going to be for these percent problems. So for every percent problem that we solve in this chapter, I'm going to have you set it up as a proportion to be able to solve it. And this is the model for your proportion. You are going to put a fraction that has the percent over 100. And then you're going to have another fraction that places the part over the whole. So this is called the percent proportion model. And everything that we do, we'll try to set it up like this. So if you learn this really well in this lesson, it will help you throughout the chapter. Now, I also wanted to say, some people like to start their proportion with the fraction about the part compared to the whole, and then put their percent over 100 as their second fraction. These are both acceptable ways to do this model as long as you put the right numbers in the right places. Okay, it's like a puzzle, and you have to put the pieces of the puzzle in the correct places to make a picture. Okay, so let's now look at some of the examples of the kinds of problems we'll be solving. They may ask you to find the percent, which will mean they will have the words what percent in the question. What percent of 5 is 4? So think about that. That's like on a quiz. Let's say you got 4 out of 5 points and you're wanting to know what your grade is going to be. That would be the same thing that this question is asking. What percent would it be if I got 4 out of 5? Second type of question is if you're asked to find the part. So when you're trying to find the part, that means that you know what your percent is and you know what the total possible is, but you don't know how many that you're talking about out of the total. So if you knew you made 80% on your last quiz and you knew that it had 5 points possible, the question would be how many points did you actually get? Third type of percent problem is when you are finding the whole. That's WHOLE, as in the entire amount. Here is an example of that kind of question. 4 is 80% of what number? Meaning that I know I got 80% on the quiz. I know that I got 4 points, but I don't know how many were possible. So that's when I would be finding the whole. Okay? Now remember, to set up the proportion correctly for these problems requires that you know where to put the parts or the pieces that will complete the puzzle. So you have to know what the part is, what the whole is, what the percent is, and whatever piece of information you do not know, that's going to be your variable. So in each of these problems, when we were trying to find the percent, we didn't know what was supposed to go there. We put a variable there. And when we're trying to find the part, when we don't know that, we put a variable there. And when we're trying to find the whole, we don't know that. We're trying to find that number that goes on the bottom there for the whole. Okay, let's look at some examples now and start talking about how to set up and solve these problems. Take a look at example 1 with me. The question says, what percent of $15 is $9? Now, I'm going to give you a really big clue right now of how you can usually identify the whole. The whole usually comes after the word of in the problem. So of 15, we know that that $15 is going to be the whole. I'm going to go ahead and put a W above that so that you remember that we said that that was the whole. All right, and then they are asking us what percent. So since that's what they're asking us, we know that we don't know what number to put for the percent, and that's where we're going to have to use a variable. And then another big clue for you is the part normally comes after the word is, and that's about 90% of the time. Now, there are a few problems where the part will be at the very beginning of the sentence. So I'll point that out to you when we see that later. Okay, so we know what the whole is. We know what the part is. We don't know what the percent is because that's the variable that we're going to have to be finding in this proportion. So let's get it set up correctly here. The part is 9, so it goes on top. The whole is 15, so it goes on bottom. The percent is what we don't know, so we're going to use a variable here, and they used n. You can use whatever variable you want. You can use x or any other letter that you choose. That's not really important. So once you get the proportion model set up correctly, you are ready to solve the proportion, and here are the steps. So here's our proportion written correctly. The next step is called finding the cross products, which means that we are going to multiply diagonally like this. We're going to find the cross products, and the reason that you do that in a proportion is because cross products in a proportion have to be equal to each other. So that allows us to make an equation that we can solve by multiplying diagonally and taking 9 times 100 and also 15 times n. So 9 times 100 is 900, right? And then 15 times n we don't know the answer to, so we're just going to call it 15n. All right? So now we have this equation that says 900 is equal to 15 times n. To solve an equation like this, you have to divide by the number that you know in the multiplication problem. So the number we know is 15 because 15 is being multiplied by n. So if we divide by 15 on both sides of the equal sign, then we're going to find out what n equals. Now you may wonder why we have to do the same thing on both sides. Well, it's an equation, and the left side is 900 and the right side is 15 times n, and the only way that we can keep both sides equal is if we do the same thing to both sides of the equation. So if you are going to divide 900 by 15, you also have to divide 15n by 15, because when you do that, something interesting is going to happen. The 15, when you divide 15 by 15, they cancel each other out and you get 1. So the 15 actually goes away when you divide by 15. And that would give you 1 times n. Well, 1 times n is still the same thing as n, just like 1 times 5 is still 5. So we don't have to put the 1 in front of the n, even though we still have 1n. We can just write n. And then 900 divided by 15 is 60. So that answers their question. $9 is 60% of $15. Okay, it's your turn now to try setting up these two problems, A and B, as proportions, and then doing the cross multiplying and dividing to find the missing number. Now, probably a good point here to stop the video for just a couple of minutes and try to do these two problems, and then we'll go over them together. Okay, so if you stopped the video and took a little time to try to set these up, you have to be able to identify what the pieces are in the proportion. In problem A, what percent of 25 is 20? So remember I said after the word of, that's always going to be the whole. So I'm going to identify that as the whole, W. And I said after is the part. So I'm going to identify this as being the part, 20. And then since they're asking me what percent, that means that that is going to be the variable that I have to find in this proportion. So let's get it set up correctly. If you want to put your percent over 100, you can start with that if you want to. I'm going to put X for the percent because I don't know what the percent is, and that goes over 100. And then I am going to put the part, which is 20, as the numerator. It goes over the denominator, which is the whole, so that would be 25. And now that I've got it set up, I can do my cross multiplying. Now, before I do that, let me tell you about a shortcut. Anytime that you can see a clear relationship between either the numerators or the denominators, it is possible that you do not have to do the cross multiplying to figure out what the missing value is in the proportion. So in this particular problem, I am noticing that there is a relationship between the denominators that's pretty easy to figure out. If I'm going to turn 25 into 100, I would have to multiply 25 by 4. Since 25 times 4 would give me exactly 100, then I can use that relationship. I call this scaling up. It's when you're making a equivalent fraction by figuring out how you get from one number to another. It's either multiplying or dividing. So 25 times 4 is how you get to 100. So 20 times 4 would tell you what the missing number is for that numerator there. So 20 times 4 is 80. So we can figure out that the answer to this, the solution, would be x equals 80. And since 80 is supposed to be the percent, then you would add a percent sign to the answer to answer their question. What percent of 25 is 20? That would be 80%. If you got 20 out of 25 on a quiz, then that would be 80%. All right, second example. Problem B, we're going to set this one up as well as a proportion. Let's take a look at that. So let's identify what we got here. After the word of, it's going to be the whole. And since $12.75 is at the beginning, remember I told you earlier that about 10% of the time, I would say, that the part is going to be at the beginning of the problem instead of after the word is. So this is one of those times when the part occurs at the beginning. So the $12.75 is the part. And then it's clear here that we're going to be looking for the percent again. So the percent is going to be our variable. And remember what I said about the models that we talked about earlier. You can put your percent over 100 first or your part over the whole first. So I think this time I'm going to start with the part over the whole. So our model this time, we're going to look at our model this way as the part over the whole equals the percent over 100. So we said that the part is $12.75. So that's what we're going to put there. Where the P is located at, we're going to put $12.75. And the whole is $50, so we're going to put $50 on the bottom as the denominator. And then over here for the percent, we don't know the percent, so you can put your variable there over 100. And there you've got your proportion set up correctly. So now we're going to do our cross multiplying. Well, wait a minute. We got another problem here where maybe we don't have to do the cross multiplying because maybe you can see that there is a clear relationship between these denominators. Again, this is called scaling up. If you can take 50 times something and get 100, that would be 50 times 2 that would give you 100. So if we multiplied by 2, 50 times 2 is 100. If we multiply the numerator by 2, then that would tell us what the value of x is. So 12.75 times 2 would be 25.5. And we were finding a percent again. So you want to add a percent sign to your answer. And so $12.75 would be 25.5% of $50. All right, let's move on to the next page. And we're going to talk about example 2. Now we're going to look at an example where you are trying to find the part. So in example 2, it says, what number is 40% of 120? So we can see that the whole is going to be 120. And this time they gave us the percent. It's 40%. And this thing that we're going to be looking for this time is the part. So that's P, and that will be our variable in this problem. So we're going to put P over 120 equals 40 over 100 to set up this proportion. And then we are going to do our cross products. Now, there's no easy way out of this one. The only way that you're going to be able to solve it is to do the cross products, to multiply diagonally. So that's what they're doing here. If you take P times 100 and 120 times 40, that will give you the cross products. So P times 100 is 100P. And 120 times 40 is 4,800. And to solve that multiplication equation, you have to divide by the number in front of P, which is called the coefficient. So we're dividing by 100. In algebra, you draw fraction bars to show that you're dividing, and then you put the number you're dividing by as the denominator. So if you take 100P and divide it by 100, the 100s are going to cancel each other out, and you'll have P. And then 4,800 divided by 100 is going to give you 48. So the answer is 48. That's the part. 48 is 40% of 120. Now it's time for you to try C and D. So this is a good place to pause the video and try to work out problem C and D, and then start it back up when you're ready, and we'll go over these. Okay, if you stop the video, let's go ahead now and talk about C. So in problem C, you should be able to identify the whole as being 60 because it comes after the word of, and they gave you the percent this time. And this number that you're going to be looking for, what number, that's going to be the part. So we're going to set this up as P over 60 equals 5 over 100. And then we'll be ready to do our cross products. So let's go ahead with that. We're going to take P times 100, and I don't have so much room to write here, neither did you. So I'm going to put 100P, and 5 times 60 is 300. And then we're going to divide by the number in front of P, which is called the coefficient. We're going to divide by 100. And they will cancel out on the left side there. We'll have P equals 300 divided by 100, which is 3. So the answer to their question is 3. What number is 5% of 60? 3 is 5% of 60. Moving on to problem D now. We see that we have the percent, and it looks like we've got the whole right here of 85. That would be the whole, and once again, we are looking for the part. So we're going to put P over 85 equals 12 over 100, and you're going to do your cross products now. So you're going to multiply diagonally like this. Okay, and that would give you, we've got 100 times P, 100P, and we've got 12 times 85. I believe that's 1,020. And then you are going to, hang on a second, I'm double checking myself here. 1,020. Minute real quick here. Let me make sure that was correct. 85 times 12. Yes, that is 1,020. Just wanted to make sure that I had that right. And now we're going to divide by the number in front of P, which is 100. And those will cancel out. So we'll have P equals 10.2. So 12% of 85 would be 10.2. All right, moving on to example 3, and now, as you might imagine, we're going to be finding, we found the percent and we found the part. Now it's time to practice finding the whole. So in this problem, we have the percent, and 18 is going to be the part, And we are looking for the whole this time because after the word of, there's not a number. There's the words what number, meaning we're looking for that variable. All right, so we set it up as 18 over W equals 25 over 100. You do your cross multiplying and take 18 times 100 and 25 times W. Then you divide both sides by 25 and you get W equals 72. So it's your turn to try finding the whole. There are two problems here, E and F. This is a good point to stop the video and work those two problems out, and then we'll go over those in just a minute or so. All right, if you stop the video, then you're ready to go over these with me. So it looks like in problem E, we have the percent, which is 40%. And we have the part, which is 26, and we're going to be looking for the whole this time. So we are going to put 26 over W because we're trying to find the whole, and we're going to put 40% over 100. And then you're ready to do your cross products. So you're going to take 40 times W and 26 times 100. And then you're going to divide by 40. And 2600 divided by 40. Let me check that here before. So that is 65. So the missing whole is 65. Okay, let's look at problem F. So it looks like we have the percent is 75%, and this is going to be our part, 84, and we are looking for the whole. So we're going to say 84 over W equals 75 over 100. So our proportion is set up correctly. We're ready to do the cross multiplying. We have 75 times W and 84 times 100. So 75W equals 8400. And we can divide by the coefficient of W, which is 75. And these will cancel out, and we'll have W equals 8400 divided by 75, which I believe is 112. Okay, so we have practiced doing examples of each type of problem. Let's move on now to the next page. I'm going to skip example 4 for right now. Here's an opportunity for you to practice a little bit more on 1, 2, and 3. Number 4 is a word problem. I think we'll actually stop and do that one together right now, because our ultimate goal here is to be able to handle word problems. And number 4, it says brand A cereal contains 10 cups of cereal. So how many more cups of cereal are in brand B cereal? And you've got pictures of the boxes here. Now, they told you that this box has a total of 10 cups in the box. So that is going to be called the whole in this problem. And brand B has writing on the front that tells us what the percent is. Brand B has 30% more than brand A. So we know the whole and we know the percent. It looks like we're looking for the part in this problem. So that would be P over 10 equals 30 over 100. And then if we do our cross products, that would be 100 times P and 30 times 10. And then if we divide by 100, P is going to be equal to 3. So that means there are 3 more cups of cereal in brand B. All right, I'm going to give you the chance now to do some independent practice. So we're going to move on here to page 5, and I would like for you to work out your problems and show your work. You can use the calculator, but I want you to do all of page 125, and that will be for a grade. So good luck with that. Let me know if you have any questions. You can message me on Google Classroom, and I'll get back with you as soon as I can. Thanks, and have a good day.